We now discuss the solution of a problem from the section Differential Calculus. The given question is on the absolute extrema of a given function in a given interval. This question has appeared in the joint entrance examination main held on 26th June 2022 in the first shift. The given question is the sum of the absolute minimum and absolute maximum values of the function f of x is equal to modulus of 3x minus x square plus 2 modulus closes minus x in the interval closed interval minus 1 to 2 is, we are given four options. Option A, under the square root of 17 plus 3 whole by 2. Option B, root of 17 plus 5 whole by 2. Option C, 5. Option D, 9 minus under the square root of 17 whole by 2. We are given a function f of x defined as mod of 3x minus x square plus 2 minus x, and we have to find the sum of the absolute minimum and absolute maximum values of this function in the closed interval minus 1 to 2. This is our given question. We now discuss the solution of the problem in detail. We have f of x is equal to modulus of 3x minus x square plus 2 minus x is equal to, and this mod of 3x minus x square plus 2, we have written it as mod of x square minus 3x minus 2, which is equal to the earlier function minus x. X belongs to the closed interval minus 1 to 2. This is equal to mod of gx minus x, where g of x is x square minus 3x minus 2. Right. Now, we make gx is equal to 0 and we find the roots of this function. And gx is equal to 0 means x square minus 3x minus 2 is equal to 0. It is a quadratic equation of the form ax square plus bx plus c is equal to 0. And solving for x, we get x is equal to minus b plus or minus under the square root of b square minus 4ac by 2a. We have computed and we got x is equal to 3 minus root 17 whole by 2. We called this root as alpha, and the other one is 3 plus root 17 whole by 2. We call this root as beta. Agreed. Now, notice that this alpha is, the value of the alpha is less than 2, but it is negative. Negative less than 2. Therefore, alpha belongs to the closed interval minus 1 to 2, and beta is in fact greater than 3. Therefore, it does not belong to the closed interval minus 1 to 2. So, there is only one alpha that lies in the given interval. So, g of x is written as x minus alpha into x minus beta. We consider two subintervals, my closed interval minus 1 to alpha. The other one is open alpha closed to. So, in the closed interval minus 1 to alpha, x belongs to it, then x less than alpha, then including alpha, then x minus alpha is less than or equal to 0. But for x in this, x minus beta is negative, combinedly less than or equal to 0, less than 0 is greater than or equal to 0 in the closed interval minus 1 to alpha, and in alpha to 2 it is negative. It is negative. So in this interval mod gx will be gx only. In the second interval mod gx will be minus gx. Therefore f of x is equal to mod gx minus x is equal to mod gx is gx minus x in minus 1 to alpha, and in alpha to 2 mod gx is minus gx minus x, and we have gx is x square minus 3x minus 2, x square minus 3x minus 2 minus x is x square minus 4x minus 2, where x belongs to the closed interval minus 1 to alpha. Minus g of x minus x will be minus x square plus 2x plus 2. X belongs to the interval alpha to 2, closed at 2n and open at alpha n. So that is the function we have. And to discuss about the absolute minimum, absolute maximum, or local maximum, local minimum, we need to know its derivative. F prime x is equal to, first derivative is equal to x square minus 4x minus 2. When differentiated, it will be 2x minus 4. When x belongs to the interval minus 1 to alpha, and the derivative of this is minus 2x plus 2. X belongs to the other half, that is alpha to 2. And that is equal to 2 times x minus 2. X belongs to minus 1 to alpha. Minus 2 taken common into x minus 1. X belongs to the other half, that is alpha to 2. We deal with two cases to discuss about local maximum, local minimum. So case 1, in the first interval minus 1 to alpha, f prime x is 2 times x minus 2, and this is equal to 0. F prime x is equal to 0. That means x is equal to 2. But notice that 2 lies outside this interval. Outside this interval. Therefore, it is not a stationary point, because we are talking in the interval minus 1 to alpha. And f prime x is equal to 0 gives x is equal to 2, but 2 does not belong to this interval. Therefore, 2 is not a stationary point. When that means f of x has no stationary points. That means there is no local extrema. There is no local extrema for this case. But however, let us see the nature of f prime x in this interval. Note that f prime x is equal to 2 times x minus 2. For all x belongs to minus 1 to alpha, it is negative. It is negative. 2 times x minus 2, x less than 2. So x is in minus 1 to alpha, therefore x is less than 2. Therefore it's negative. It's negative. So f prime x is negative in this interval for all x belongs to this interval. Means f of x, that is x square minus 4x minus 2, is strictly a decreasing function in the interval minus 1 to alpha. So therefore f of minus 1, the value is computed, it is 3, greater than or equal to f of x, because it is strictly increasing for all x belongs to the interval minus 1 to alpha. And for the other endpoint, f of alpha is equal to minus alpha, we have computed, and alpha is 3 minus root 17 by 2, minus alpha is root 17 minus 3 by 2, which is less than or equal to f of x. That means it is actually, by definition, there is no local extrema, but these are absolute maximum at minus 1, and the value is 3, and absolute minimum at alpha, the value is square root of 17 minus 3 by 2. Is it true? And it has no local extrema. Agreed. So these are our observations, and we continue our discussion in the next slide. Now we have already considered case 1. We have seen this one. And it has no local extrema. But at the end points, f of minus 1, it has a absolute maximum. At alpha, it has an absolute minimum in this interval minus 1 to alpha. Yeah. We deal with case 2. In the second half, the interval alpha to 2, f prime x is minus 2 times x minus 1. And equating to 0, f prime x is equal to 0, it will give you x is equal to 1. 1 belongs to the interval alpha to 2. Therefore, x is equal to 1 is a stationary point. And now we apply the second derivative test. F double prime x is equal to minus 2, which is negative. At f double prime 1, f double prime x is minus 2. F double prime at 1 is minus 2, which is negative. Therefore, by second derivative test, f of x attains local maximum at x is equal to 1 in this interval alpha to 2. And the local maximum is, f max is the value of f at 1. And what is the function? The function is in alpha to 2 minus x square plus 2x plus 2. Evaluate at x is equal to 1. We get the answer 3. And that is the local maximum of f in the second part of the interval. Agreed. We continue in the next slide. We have seen case 1 where there is no local extrema. In the case 2, we have a local maximum at x is equal to 1 in the second half of the interval. And to talk about absolute minimum and absolute maximum, what you have to do is, whatever local maxima, local minima the function has, take them and take the values of the function f at the end points of the intervals also you have to consider. Then you take the totality of these values and take the maximum of that is the absolute maximum. The minimum of that is the local minimum. So now let S is equal to the set consisting of the values, the value of f in the first interval at the end points. The end points in the first interval is minus 1 alpha, f of minus 1 is 3, f of alpha is minus alpha, that is equal to root 17 minus 3. It is not root of 17 minus 3, it is root 17, root is over, minus 3 by 2. And in the second half, it has a local maximum at 1, f of 1 is 3, and f of 2 value, that is the extreme, that is the end point here, alpha value we have, and at 2, f of 2 is 2. So with all these things, you take absolute maximum as maximum of S, that is the maximum of these values is 3, and the absolute minimum of fx is the minimum of S, it is root 17 minus 3 by 2. Yes, it is now written correctly. Here it should be the same as this one. There is a topographical error here. So minimum of Sn is the minimum of all these things is root 17 minus 3 by 2. So the absolute maximum is 3, absolute minimum is root 17 minus 3 by 2. The sum of the absolute maximum and absolute minimum values of fx in the whole interval, that's what we wanted. In the example. So absolute maximum is 3, absolute minimum is root 17 minus 3 by 2. Simplify, you will get 3 plus root 17 by 2. That's the sum of the absolute maximum, absolute and absolute minimum. Let's look at our options. Our answer appears against option A. Therefore, the answer for this question is option A. That is the detailed discussion of the solution of the problem on the absolute extrema of a given function in a given interval. and it is a good question. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.